Hello, welcome back to the final exam review. We're going to cover a couple problems in this video, starting with problem number 12. It says a researcher conducts a study on people who were abused as a child and whether or not they later commit a violent crime. The sample data obtained by the researcher are summarized in the following table with some spots left blank. So across the top, we have child abuse victims and then the control group. So they were not child abuse victims. And so let's get the total there. We have 908 and 667. And then along the rows, we have committed a violent crime and did not commit a violent crime. So we have 155. And then we have 1,420 for a total of 1,575. And always make sure that your columns and your rows total to be the same amount. It says how many had committed a violent crime? So committed a violent crime would be 155. How many people had been abused as children? So 908. How many people were sampled altogether? And that would be the total of 1,575. What proportion had been abused as children and committed a violent crime? So abused as children and committed a violent crime would be 102. And it says proportion, so it's 102 out of the 1,575. And we can get that. So 102 divided by 1,575. 0.0648. F says, if a random subject is selected, what is the probability that they have been abused as a child or committed a violent crime? So have been abused as a child, 908, or committed a violent crime would be the plus 155. And then we have to subtract away the overlap, the 102, out of the 1,575. So 908 plus 155, subtracting 102, is a total of 961 out of 1,575. Comes out to be 0.6102. Is this an example of an observational study or designed experiment? And this is definitely an observational study, because you could never ethically make someone be a victim of abuse. You can never make one group be victims of abuse. That would not be ethical. Okay, we're going to skip for similarity of problems. I'm skipping to problem 16 to keep some other problems that are similar together. Determine whether the sampling method is independent or dependent. Indicate whether the response variable is qualitative or quantitative. A researcher wants to know if the mean length of stay in for-profit hospitals is different from the mean length of stay in not-for-profit hospitals. He randomly selected 20 individuals in the for-profit hospital and matched them with 20 individuals in a not-for-profit hospital by diagnosis. So, he wants to know if the mean length of stay in for-profit is different from the mean length of stay. He randomly selected 20 in the not-for-profit and matched them with 20 individuals in the not-for-profit. So it says match them, but you can never actually tie exact individual to individual. So the mean length of stay would have to be independent. And it would be quantitative because they're measuring how long they stayed in the hospital. Oh, well, wait a minute here. They match them by diagnosis. Okay, so by diagnosis, I'm going to change that because they matched them, and it must have been like patient at that for-profit hospital matched with the same diagnosis at a not-for-profit hospital. So re-looking at that when I saw the by diagnosis, that would be a dependent match pairs because they matched them. So two people with maybe breast cancer, and then two people with kidney cancer, and then two people with colon cancer, what we would say. So that's why they're dependent, matched pairs. Okay. B says an urban economist believes that commute times to work in the South are less than commute times to work in the Midwest. He randomly selects 40 employed individuals in the South and 40 employed individuals in the Midwest and determines their commute times. Okay. These are definitely independent because one group is from the South and one group is from the Midwest. And they're measuring commute times, so it's still quantitative. Next up, we're going to look at problem 13. In a Gallup poll survey conducted November 19th through the 21st of 2004, of the 1,015 American adults surveyed, 569 stated that they believed that the U.S. was not winning the war in Iraq. Find a 95% confidence interval estimate in the percentage of all American adults who believe that the U.S. is not winning the war in Iraq. Show our work. Okay. So we're saying we're estimating a percentage, so it's going to be proportions. And so we need to have a p hat. P hat is equal to x divided by n. And so that's going to be the 569 divided by the 1,015. And so we're going to go to Desmos. And I'm going to find out that proportion of 569 divided by 1,015. And so my p hat is equal to 0.5606. And so we're going to be using p hat plus or minus a z of alpha divided by 2 times the square root of the p hat times 1 minus p hat divided by n. And that formula, I'll show you in just a moment, but right now we're going to go to the confidence interval for one proportions in Desmos because we can enter our sample size and then we can enter our p hat, which we found, or you can calculate. So we could even put this in just to be sure we have the right one. We do. And then we're not doing the test H0 because we're not doing a hypothesis test, but we do need to put in our alpha. And because we're doing a 95%, it is 0.05. So then we can go down to our options and we're going to choose this one here, this one right here that says confidence interval. And there they gave it to us right there. You could drop the drop down menu, but there is our lower bound 0.53, 0.5301, and our upper is 0.5911. And going back here to our paper, this is the formula that we're using, and our p hat is the 0.5606. So here's our confidence interval. Without any work, would a 90% interval for the population be larger, smaller, or no different? So changing the confidence is changing our Z alpha. And so we can remind ourselves, if we lower our confidence, we're going to go from 95 to 90. That means our alpha is going up. And so as our alpha goes up, our Z value goes down. T value or Z value. They both decrease as alpha goes up. So the Z is going to go down, so it's going to get smaller. If you want to conduct your own study about people's views about whether America is winning in Iraq, using the Gallup poll as a prior study, how many people should you poll so that you have a 98% confidence with a margin of error of only 4 percentage points? Okay, we're going to use this 0.5606 as a prior study. So if we go back to our confidence interval page on the formulas, at the bottom are the sample sizes. And we're talking about proportions, and it says with an estimate. So because we have an estimate from the prior year, we're using this one over here on the left. So let's rewrite that. That's n equals p hat 1 minus p hat. This is the estimate from before. And then the z alpha divided by 2 over the error, whoops, all of that squared. So we're using the 0.5606 from above times 1 minus 0.5606, and then Z alpha divided by 2. They want a 98% confidence interval. So our alpha is 0.02 and alpha divided by 2 is 0.01. So I'm going to go to my Z of 0.01 and look. Remember at the bottom here, I added my alphas so I could quickly get the Z. So the Z for the alpha is 2.326. 2.326 divided by the error. They want it within 4 percentage points. So that's 0.04. We have to turn that to a decimal, and then we're going to square that. So I'm going to put this all in to my Desmos screen here. So I've got 0.5606. 1 minus 0.5606. And then I've got 2, 6 divided by 104, parentheses squared. So it looks like our sample size is going to be 832.94. But remember, we always round up to the nearest whole number. So 833 should be the answer. And then, last but not least, it says, suppose that the spokesperson for the Democratic Party made a claim before the election that more than 52% of American adults believe that the U.S. is not winning the war in Iraq. Test their claim with a 0.01 level of significance using the Gallup data as your sample data using the p-value method. Okay, so HOHA. So we think the P is equal to 0.52, and they think that it's more than 52% believe that they're not winning. So they believe it's bigger than 0.52. And step 2, alpha is going to be 0.01. And the cool thing is we can just go back to our program that we had open and look there because we already have our data in. So instead of choosing the confidence interval, I can just go up here. I do need to change my P0 because that's going to be 0.52 because that's what they're testing against. And we can see here that our Z is 2.5885. And so we're going to go down and we're testing a greater than. So it looks like our p-value is equal to 0.0048. So if I go back to my paper, here's our p-value. It's definitely less than our alpha. And we are definitely rejecting. So we do reject H0. So step 6 says there is sufficient evidence to support the claim that more than 52% believe we are not winning the war. We were not winning the war at that time. So there is sufficient evidence to say that. So that is the end of this video. Catch me back for other videos to help support you in studying for the final exam.